Hi there. So this is part 2 to the study guide. So this is, we're going to review the discriminant and solving quadratic equations. So we're going to do a lot of factoring and solving. And then I'll do a separate video for all the word problems. Hopefully chunking it out like this is more helpful. So at the top here, and this is page 3 of the study guide, we have find the discriminant of each equation, then determine the number of solutions, so how many there are. So remember the discriminant. Now that you know the quadratic formula or you have been exposed to it, this b squared minus 4ac is what is under that root sign in the quadratic formula. This is the radicand. And remember, if you wanted to do kind of a quick check, and sometimes you will be asked to identify what is the discriminant. You can very quickly, depending on what your equation is, you can identify the values for A, B, and C, plug it into this discriminant formula, and then it'll quickly tell you how many solutions you have. So these are not the actual solutions, but it's how many there are. So if your D, so if you plug this in and your D is greater than 0, you're going to have, so meaning a positive number, you're going to have 2 solutions. If D is 0, you're going to have 1 solution. And if D is a negative number or less than 0, you're not going to have any real solutions. You will have other solutions, but this is not going to be real, okay? So let's try it for number 18. So I have my A. I'm going to identify my A, B, and C. My A is -1. My B is 7. And my C is -15. So now I'm just going to plug in these values into this discriminant formula. So I have 7 squared minus 4. A is -1. And times C is -15. So things I notice is that I have 3 negative signs here. So I am going to end up subtracting whatever the product is of these 3 numbers. I'm going to subtract it because negative times a negative is positive times negative is negative. I like to always think of it that way. So now I have 49 from 7 squared. And then when I combine all these together, well, I know that 4 times 15 is 60, and it's going to be negative. Okay. So 49 minus 60, well, that is equal to -11. So if you go back to our tips here, right? Well, if it's a negative discriminant, there are no real solutions. So I get to go ahead and check that off. Okay. So let's go to the next one. So I have A is equal to, well, that's the quadratic term. A is 3. I have B is equal to -12. And my C, I don't have one. So C is equal to 0. Okay, so now let's plug it in. So I should have -12 squared. I already know that's 144, but I get ahead of myself. Minus 4 times A, right, times C, which is 0. Well, I already know, right, that this, because this 0 is here, it wipes all of this out to be 0. So I end up with 144 minus 0 because of that 0 property. It likes to annihilate things. So now I have 144. So if it is, let's look here, right, greater than 0, I'm going to have 2 solutions. And you could probably already tell, if I had to take the square root, because our next step, if we were doing the quadratic formula, would be to take the square root of 144. So I would have a positive 12 and a negative 12, just thinking ahead. Last but not least, I have my A is equal to 1, my B is equal to -20, my C is equal to 100. -20 squared minus 4, A, C. Okay, so now I have -20 squared is 400. Oh, and look at that. I have 4 times 100. That's 400. That equals 0. And then going back to here, if it is, right, equal to 0, I have 1. You could tell there was going to be a variety, right? Okay. So I'm just going to do the odds, I think. Well, I'll just do a little here and there. Okay, so for this one, this is a standard try, right? This is a try. And I'm going to do the product sum game to answer this. Okay, so that's how I would factor this. So I'm going to multiply to negative 45. I'm going to combine to 4. And I know that I have a 9 times 5 looks pretty good to me because it's 4 apart. I know it's going to be positive 9 and negative 5. Okay, that's going to check out. So in factored form, x plus 9, x minus 5 equals set to 0. And then solve both sides. So x is going to equal negative 9 and x is going to equal 5 when I solve and isolate my x. Let's write it in set form. Okay, that's the answer. Let's go to 2. So for 2, I see that, well, I could maybe, let's think about this. Do I have a linear term here? Do I have a b term? I don't. So when you don't have a b term, you can think about square roots, see if that works. So I want to put the c on this side. Okay, so I'm going to do the square root. I'm going to label my method here. So I'm going to write 2x squared, and I'm going to add 9. Okay, so I'm going to end up with 48 over here. Okay, so now I want to isolate my x. So first thing I'm going to do is divide both sides by 2. I'm going to end up with x squared equals, well, half of 48 is 24. I'm going to take the square root of both sides. And now I have x equals, well, 24. I can think of that as, well, it's not a perfect square number, but I can simplify that. So square root of 24, it also equals the square root of 4 times the square root of 6. Okay, well, I know the square root of 4, so I could do 2 root 6. And remember, it's going to be those two solutions, right? Positive and a negative. So x is equal to positive, negative. Well, that is the answer. Oh my goodness. I got to close my window here. Okay. (23) and 24. Okay, so this one looks like, well, a is equal to 1. That's what I notice. B is an even term. Is a trinomial, and I already know I can't just factor this. Like, there are no factors to get to 3 that are going to, like, combine to 10. So for this one, I'm actually going to try to complete the square. Okay, so this is how we do it. So x squared, I'm going to take half of my b value. Well, first, you have to get your c onto the other side, because remember, you're trying to manipulate a new constant here. So let's just write that in the right form, okay? Now I want to take half of my linear value, negative 5. I'm going to square it, and I'm going to add it to both sides. So I'm going to have x squared minus 10x plus 25, remember, because I'm adding it here, equals 3 plus 25 here. Okay. Now I'm looking for, now I just created a perfect square here. So I could do the product sum game, right? But hopefully you already see it. Okay, so I have to have 5 and 5, and they're both going to be negative. Okay? So I'm going to have x minus 5, right, squared, equals, combine those two, and that's 28. Take the square roots of both. So now I get rid of my root sign there. And then I'm going to have this plus or minus 28. Now I can simplify 28 because it also equals the square root of 4 times the square root of 7. So now I'm going to add 5 to both sides, and I'm going to end up with x equals 5 plus or minus 2, because I'm taking the square root of 4 and taking it outside, root 7, because I can't simplify it anymore. And that is your answer. Okay, so for this one, let's see. Oh, I like this one because I think I can do the greatest. Let's do the greatest common factor here. So I'm going to move this over. I'm going to rewrite this 16x squared minus 10x equals 0. And I want to go ahead over here and I want to find the greatest common factor. So I think that 2 and x both go in. Whatever your greatest common factor is, put it outside, then divide it out. So I'm going to divide out both these terms, equals 0. Okay, now I can simply set both of these to 0. 2x equals 0. Well, clearly x is 0, and then I have 8x minus 5 equals 0. Add 5 to both sides, 8x equals 5. And then divide out my 8. I think I already know my answer. It's 5/8, okay? So x is equal to the set of 0, comma, 5/8. Okay, so for this one, maybe I'll just do this one page. It's a lot. For this one, I see that a is greater than 1. It could be a slide and divide, or maybe I should just go for the quadratic formula. I'm going to do that. I think that seems better. And I'm going to get my calculator handy if I need it. I'm going to do my quadratic formula. And I'm going to write it again right here. It's always good to rewrite it. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay. I've got my a is 3. I've got my b is negative 8. Got my c is negative 8. And then let's go ahead and plug it in. So x equals, let's see, negative b. So I have a negative 8. So that turns it to positive 8 plus or minus b squared, negative 8 squared minus 4ac. I notice that there are 2 negative signs, so I know that I'm going to end up adding whatever this is. So I have 8 plus minus square root of 64. And then when I combine, let's see, I have 12 times, I already know that's 96. So I'm going to add 96. And then I'm going to put it over my 2a. So I have 2 times a, so 2 times 3. Over 6. X is equal to 8 plus or minus, when I add 64 and 96, that's 6 plus 4 is 0, so I'm going to end up with 160 over 6. Okay, so I'm going to keep going because I want to simplify this, right? So I have 160 that I can simplify to, well, it's 16 times 10, right? 16 times square root of 10, and 16 is a square number, so I could call this 4 root 10. So then here, and I can now rewrite this as x is equal to 8 plus or minus 4 root 10 over 6. And now I can divide, right? I can simplify these terms to, well, I know that there's a common factor with 8 and 6. And that could also, if I could just split both in half, right? And I could also split both of these in half. Okay, so I could divide that plus or minus 2 root 10 all over 3. Okay, so we have the quadratic formula. Let's see, I'm not going to do this. This would be the quadratic formula, though. If you're looking to see, I can already tell if you're going to continue to do these, right? On the back side, so this, let's see. Let's check out this one. I'm not going to do them. You could look at the answer key though. So this one was going to be to complete the square. Let's see. Oh, this is going to be a slide and divide. This one is going to be greatest common factor. So I'm going to do a GCF here. It's going to be kind of a two one, right? I have to 2 steps here, and then a basic trinomial. This one I can tell is going to be square roots. I already like the 25, right? This is going to be square roots. If I look at 31, I am going to do, oh, I think if there's no linear term, like just like this one, I'm going to do square roots here. And I'm going to let you do these. 32, I'm going to do the quadratic formula. Okay, and let's see what my time is looking like. I think that's plenty of time. Good luck.